Hi, I'm David.
I'm Jonathan.
And I'm Luke, and this is data augmentation techniques and style shifting GANs. With the rise of deep learning, it's become ever more important to have access to large data sets. For image data, we've used traditional data augmentation techniques to increase the amount of data we have. This includes stuff like cropping, rotating, and flipping images. Today, we're going to explore how we can use GAN generated images and also style transfer as data augmentation techniques. We'll be doing this on the CFAR 10 dataset. As a follow-up, we also tried filtering and grayscaling as a new traditional technique for augmentation.
So just as a model summary of what Luke mentioned earlier, we are running 3 separate experiments. The first is traditional augmentation, which also includes filtering and grayscaling. We have a conditional GAN that's going to generate images for each class. And finally, we have a CNN that does style transfer across both generated images and original images. Our augmented data set is therefore a combination of these 3 experiments, which we then feed into a classifier to get our results.
So for our results, you can see that our baseline with only the CFAR data and no augmentation received like a best validation accuracy of 86.9%. But with filtering, grayscaling, and then traditional augmentation, we got our best result of 91.6% accuracy on the validation set. We can see that the GAN generated data and the stylized data was similar to the baseline performance, but could have been better.
So as a result summary, our traditional data augmentation and filtering worked extremely well. You can see in the lower right, we've thrown up an example of what it means to adjust brightness, contrast, and saturation. What we believe this kind of helped was kind of capture some different features that the original CFAR 10 dataset may have overlooked.
We also noticed that thresholding could lead to potential possible improvements, and this just means filtering the generated data based on how good they look.
Yeah, and finally, if you look to the bottom left, you can see examples of what it means to stylize an image. So here we have a frog and then 2 different stylized versions of it. As you can see, there's some features that are captured in this images, but largely there's probably still a lot more work that could be done to produce better stylized images.
So for future work, what we want to do is we want to evaluate on different data sets. A lot of people have used MNIST in the past, and it would be super cool to kind of compare what our results might translate over to other data sets. We wanted to experiment with different backgrounds rather than just textures. In the experiment, we kind of looked at just like 2 pieces of art, but we want to see if we can do better, such as like nighttime and daytime. And how we can do that is by applying image segmentation using CycleGAN, so we can accurately detect the object and then switch out the background as necessary through style transfer. Thank you so much.